Today, we're going to talk about Docker. Now, that might sound a little technical, but trust me, this is a technology that completely changed the game. It solved one of the oldest, most annoying problems in software, and it's the reason the apps you use every day actually work.
So, let's start with a scene that pretty much every single person in tech knows all too well. Picture this. A developer says, "The code works absolutely fine," and the tester just replies, "But it doesn't work on my system." This right here, this is the dreaded, "it works on my machine" problem. And honestly, it's been the cause of so much pain, so many late nights, and just endless frustration in the software world.
Now, we're calling this the works on my machine problem, and it's so much more than just a funny little argument between colleagues. No, this points to a huge, fundamental flaw in how we used to build software. You see, the developer's computer, the tester's computer, and the server where the app actually runs for customers, they were all like different planets. Each one had its own unique setup, which meant code that worked perfectly in one place could just completely fall apart in another.
And trying to get a new developer up and running, it was a nightmare. People called it the matrix from hell. You get this long list of instructions. Okay, you need this exact version of the database, but wait, you also need that version of this other tool. And oh, by the way, they don't like each other, so you have to install this third thing to make them talk. It was this incredibly fragile, tangled web of dependencies, and it was just a mess.
So obviously, people tried to fix this. Let's take a quick look at how we got from that mess to where we are today. A little journey from monoliths to VMs.
All right, so first up, we had what's called a monolithic architecture. And you can think of it just like the name sounds, a giant single block of code. Everything, the user login, the payment system, the comments section, it was all tangled up together in one massive application. In the beginning, this was actually pretty simple. But as the application got bigger, it became a monster. A tiny bug in some forgotten feature could bring the whole thing crashing down. Trying to make a small change was like playing Jenga with a skyscraper.
So, the industry came up with a much smarter idea: microservices. Instead of one giant monolith, you break the application down into lots of tiny, independent pieces. The login system is one piece. The payment system is another. They're all separate. This was a game changer. Now you could update one part of your app without any fear of breaking everything else. It made everything way faster and way safer.
Okay, but wait. If you solve one problem, you often create another, right? So now you've gone from one big application to maybe 50 small ones. Where do you run all of these things? How do you make sure they don't start messing with each other's settings and create a whole new kind of dependency nightmare?
The first real answer to that question was the virtual machine, or VM for short. And what is a VM? Well, it's exactly what it sounds like. It's an entire computer, but running in software on top of another computer. It has its own operating system, its own hard drive, everything. So the idea was simple. Just give every single one of your little microservices its very own private computer to live in. Problem solved, right? Total isolation.
Well, kinda. The problem with VMs is that they're huge. They're incredibly heavyweight. Think about it. Every single VM needs a full copy of an operating system, like Windows or Linux. That means each one takes up gigabytes of space and can take, several minutes to start up, just like a real computer. It works, but it's really slow and incredibly inefficient.
And that inefficiency, that wastefulness, that created the perfect moment for a completely new idea to come along. This is where Docker finally steps onto the stage and offers us a much, much better way to do things.
So what was Docker's big idea? It's something called a container. A Docker container is a super lightweight, totally self-contained little package. And inside that package is your application and everything it needs to run. I mean, everything. The code, the right libraries, the specific settings, it's all bundled up together. And the beauty is, that package is guaranteed to work the exact same way no matter where you run it.
Honestly, the best way to think about it is like one of those big metal shipping containers you see on boats, right? It doesn't matter what's inside. It could be bananas, it could be TVs, it could be cars. The box itself is a standard shape. That means any crane, any ship, any truck, anywhere in the world knows how to pick it up and move it. Docker containers are the exact same thing, but for software.
So if you look at the comparison between VMs and containers, you see this massive difference. And the secret sauce, the reason why, is actually pretty genius. A VM, remember, has to have its own entire operating system inside it. But a Docker container, it's much smarter. It just shares the operating system of the computer it's running on. By getting rid of that huge duplicated piece, containers are tiny. We're talking megabytes, not gigabytes. And they start up in seconds, not minutes. It's a huge leap in efficiency.
Okay, so containers are awesome. They solve the packaging problem, they solve the works on my machine problem, but their success created a new problem of scale. What happens when you're not just running a handful of containers? What happens when you're a big company like Netflix or Google and you're running hundreds of thousands, maybe even millions of them?
I mean, just think about it for a second. Servers in a data center fail all the time. So what happens if one of those physical machines just dies? What happens to the hundreds of containers that were running on it? Does your favorite app just go offline? Does the website crash?
Well, no, it doesn't. And that's because of the next piece of the puzzle, something called container orchestration. You've probably heard of the big one, Kubernetes. An orchestrator is basically the conductor of your entire container symphony. It's a system that automatically manages everything, making sure all your thousands of little containers are working together perfectly.
You can think of it as the brain of the whole operation. Its job is to automatically put containers where they need to go, to create more of them if, say, you get a sudden rush of traffic, and, this is the really cool part, to handle things when they break.
And this is where the real magic happens, self-healing. Let's say one of your servers fails. The orchestrator sees that happen instantly. And what does it do? It automatically starts up new replacement containers on other healthy servers. There's no human involved. This is happening all the time, behind the scenes, and it's the reason why the big services you use almost never seem to go down.
All right, let's bring this all together. We've talked about a lot of techie stuff, but why should you care? How does this actually affect you?
The answer is containers power pretty much everything now. They are the invisible engine that runs the modern internet. Every time you stream a movie, order food, or post a photo, you're using services that are almost certainly running inside millions of these little containers, all buzzing away in some data center.
So what's the big takeaway here? Docker and containers created a universal standard, a common language for software. This means developers can finally build things without worrying about where they'll run. It means companies can push out new features faster and more safely. And it means our favorite apps can handle massive amounts of traffic without breaking a sweat. That old, frustrating problem, it works on my machine, it's finally been solved.
When you step back, the story of Docker is just an amazing example of how a single, really smart idea can completely change an entire industry. It makes you wonder, right? With this huge problem now in the rearview mirror, what's the next big thing? What's the next big challenge that's just waiting for its own revolutionary idea to come along and change how we build the future?